Surface area of a frustum. A frustum is actually a cone which has been cut a halfway or 3/4, whichever way they cut it. So this is a cone. When a cone is cut, it forms a frustum. So if I extend this line, we will have a big cone and then small cone cut from it to form a frustum. So as you can look at this frustum here, if I extend it upwards, I will form a big cone. There is this big cone and then there is this small cone. So a frustum actually is a figure formed when a cone has been cut. So there are things we need to understand from the frustum. So a frustum comes from a big cone. Look at this cone. There's this cone and there is, here we have two cones, the big one and the small one. So once the small one has been removed, it forms the cone, the frustum. Now this is the big radius, small radius. From here up to here, or from here up to here, is the big slant height. We use capital L. From here up to here is the small slant height, the slant height of the small cone. This is the radius of the small cone and this is the radius of the big cone. This is the height of the big cone and this is the height of the small cone. Having that in mind, it will be very easy to do it. So how do you get the surface area of a frustum? It is given by, you calculate the curved surface area of the big cone, then subtract curved surface area of the small cone, as simple as that. Now that we know how to calculate the surface area of a cone, we calculated that of the big cone, we subtract that of the small cone. Find the surface area of the fabric required to make a lampshade in the shape of a frustum, whose top and bottom diameters is this and that respectively, and the height is 12. So we have been given that the frustum is, the diameter of the small is 20, so the radius is 10. The big one is 30, it means the radius is 15. From here up to here, it is 12. So it is the duty of a student, once you have a frustum, to extend and form the cone, the big cone. It is your duty. So once you have extended, now we need to we have the height from here up to here. We do not have the height of the full, we must get the height, the full vertical height of the cone. So we do that by using similarities we learned in Form 2. So we say that small radius 10 divided by h, or we can use either. We can even say h over this small height divided by 10 would be equal to small height divided by the radius is equal to the big height, which is 12 plus h. 12 plus h divided by the radius, the big radius, 15. So you cross multiply, we have 15h is equal to 120 plus 10h. 15h minus 10h is equal to 120. 5h is equal to 120. Divided by both sides by 5 and h is equal to 24 centimeters. Now from here up to here it is 24. So it means from here, the top to the bottom, the vertical height is 36 centimeters. So capital H is 24 plus 12, which is 36 centimeters. We need capital H because we know how the formula for calculating the surface area. Now since we have that, we are missing one thing. We need L, capital L and small l, slant height for the big one and the slant height of the small, because the formula is pi r l, right? So we need this. How do you do it? So let us get the slant height L. L, the big one, is given by From here up to here, it is 36 square plus 15 square, which gives us, and then we get the square root, we get the answer, which is 39 centimeters. Small slant height, the slant height of the small cone equal to the square root of 10 square plus 24 square. This one gives us 26 centimeters. Now, having that, we know that surface area of a frustum surface area of a frustum is given by curved area of big cone minus curved area of small cone, which is equal to by RL minus by RL, which is now in this case 22/7 times the big radius, which is 15, times capital L, which is 39, minus 22/7 times small r 10 times small, that is 26. The same as 1838.57 minus 817.14, 1021 centimeters square to 4 significant figures. Remember that.